Let's talk some about factoring. So when you have an algebraic expression like one of these, factoring says, is that the product of two other algebraic expressions? So here, notice 3x and 6 are both multiples of 3. So we could really say this is the same as 3 times the quantity x plus 2. You could think of factoring as undistributing, right? Distributing is the process of going from here and saying, well, 3 could be multiplied times the x plus 3 times the 2 to get to here. This is undistributing. Now, it has roots in the area of shapes. Okay, so let me just show you the geometry of this problem for a moment. Let's imagine you had 3 x's. What do 3 x's look like geometrically? Well, the area, x times 1, that area would be x plus x plus x plus 6 1-by-1 boxes. How do I think about factoring that? That's basically making a rectangle. A rectangle is base times height, right? So let's think about that. Perhaps I have these 3 boxes, and I notice that 3 show up a lot. So I'll just stack those boxes. I'll say, hey, the length of this side is 3. The length of this side is x. Now let's put those 1-by-1 boxes in here. Well, there's my 6 1-by-1 boxes, and notice I have a rectangle that is 3 by x plus 2. That's exactly what factoring was. So hopefully that gives you a little bit of intuition for what's happening here. Let's now move to another problem. Now, you don't have to just factor out numbers. These have a 7 in common. They also have an x in common. So we could say this is equal to 7x times x, right? If you distributed, that would be 7x squared plus 2, because 7x times 2 is 14x, okay? Again, we're sort of checking by saying we could go backwards. Here I've got 3 terms. Notice there doesn't seem to be a number or a power of x that factors out of all 3, but here I can actually factor as the product of 2 parentheses. If I have an x squared, one way you could factor is you could think that's an x times x, okay? Now, if I have a 6 and I'm trying to get that as the product of 2 things, I have a couple of options if I'm working with integers. I have 1 times 6 and I have 2 times 3. Oh, and to have it be negative, one of them has to be negative, right? So I could have something like plus 1 minus 6, minus 1 plus 6, and the same thing with the 2's. Now, what happens here? If I had that, is that true? Well, here's what you'd have to do to check that. You'd have to actually distribute. You'd have to say, well, this term applies to the x, and it applies to the negative 6. Okay, so negative x plus 1 times 6. So I don't know about that equal sign, but I know if you had that, it's equal to that. Now that x distributes here, and I get x squared plus x minus 6x minus 6. So I get my x squared like I knew I would. I get my negative 6 like I knew I would. I get negative 5 x's in the middle. That's not really what I was going for. But it's just the wrong sign, so I can use that intuition to go back here, make that negative, and that positive. That'll actually make all of this work out just marvelously. Oops, that's still negative. Okay, so there's sort of a shorthand rule a lot of people use to do this kind of factoring. They say these 2 terms have to multiply to negative 6. They have to add to the linear coefficient, which is 5 in this case. Okay. Now there's no guarantee that you can factor something like this, but it's really nice when you're able to, and often you can. Here's the last problem. Notice that all 3 of these terms have a 5 in common. All 3 of these terms have not just one x, but x times x. This has an x squared, an x squared, an x squared. This term is 5x squared times 2x to the 6th. Notice if you multiply those together, you'd get 10x to the 8th. This term you just need an x. 5x squared times x is x to the third. This term, we just need a 3. 5x squared times 3 is x squared. Now, that's a nice factorization. You probably haven't seen a lot of problems that you're supposed to factor with an x to the sixth, and there's a good reason why. All of humanity, all of the mathematics discoveries that we've come up with so far, we don't have a way to factor degree 6 polynomials in general yet. We don't know yet. And I think it's important to point out, we show you in mathematics classes what we know. We know how to factor things that just have x terms. We know how to figure out if things with x squared terms, these are called quadratics, are factorable. We know x to the third, cubics. We know x to the fourth, quartics. But we don't know about x to the sixes yet. And so we would have to leave it here. We'd say, I know 5x squared is a factor, but that's as far as I can factor it.